what we're going to do is we're going to set up a number of a numerical exercise and then go through a number of multiple choice questions on the monopolistic competition model to help build some of your intuition with how this model might work with real numbers. So let's consider the US industry for industrial lasers. I guess it's an industry producing lasers for industry. And so, as you imagine, to make lasers, presumably you have to buy really fancy equipment. I presume it's, I don't know, lasers are tough to make. You probably need diamonds, some metal, stuff like that. And so it's not super easy to get all of these things. And so we're going to suppose that upfront investment before you even produce one industrial laser has to be $10 million. To me, that sounds pretty low, but maybe you can make a laser for only a fixed cost of $10 million. The variable production cost, or the marginal production cost, the cost of producing each additional industrial laser, is going to be $50,000. Again, we just saw that the market price is going to be given by P bar is equal to C plus B over N, where N, again, is the number of firms in the market, and B is the sensitivity of consumers to price. And we're just going to call B as given by 1 over 200. And so plugging in for those numbers here, well, we can plug in for C here, B there, and then we'll solve for the number of firms later. But for now, we just get the PP curve. So recall that this is the PP curve, is just equal to 50,000 plus 200 over N. Likewise, we're going to say that the market size in the US for lasers is $4.05 million. And so the question is going to be, given this setup with increasing returns, why do we consider a market with monopolistic competition? And why not perfect competition? Well, the reason is that this fixed cost is really large. And so in perfect competition, we'd have to set a price equal to the marginal cost, which is just $50,000. But notice that each firm, before producing any laser, has to charge a price of, has to pay just $10 million just to enter the market. And so likely, if you're only charging exactly the marginal cost of producing each unit, you never be able to cover the fixed cost. And so no firm would ever want to produce industrial lasers under perfect competition. Because if they did, their profits would be negative. Question 2 is going to be why the market price depends negatively on the number of the firms in the market. So I commented a little bit on this last time, but I mean, one reason is just mechanical. If we have that each firm is producing the same quantity, and that quantity is given by S over N, then we can notice that that as N increases, then each firm is going to produce a lower amount of output, and so they're going to have to charge a higher price because they're only splitting up that fixed cost over relatively fewer units of output. The other answer comes from the demand side, and is what's given here, and that's going to be that as more firms enter the market, we can think of competition in the industry increasing, making demand for each firm more elastic or more sensitive to prices. That's going to reduce the markup, and it's going to lead to lower prices, where the markup is, again, going to be defined as what the price each firm charges above its marginal cost, which is going to be given by Bn. So question 3 is going to ask to sketch the equilibrium in autarky for the US with the market price in the vertical axis and the number of firms in the horizontal axis. So what we can do is we can just draw the CC curve here as before, and the PP curve here, and then I'll show you how we can come up with these numbers. But question 4 asks us to figure out what the equilibrium price of lasers is and the equilibrium number of firms. So how did we solve for the equilibrium price of the equilibrium price and number of firms previously. We just set the PP curve equal to the CC curve. And so if we have that the marginal cost is 50,000 and the fixed cost is 10 million, then the cost function for each firm to produce a quantity Q of industrial lasers is going to be given by C times Q plus F, which is 50,000 plus 10 million. And so AC is going to be equal to 50,000 plus 10 million. I'm just going to write 10M over Q. So that's going to be my average cost. What's the price going to be given by? Well, recall that we said that price is just going to be equal to 50,000. So price is just going to be equal to 50,000 plus 200 over N. And hopefully the text doesn't cover up this. So this is setting price equal to the average cost. And so let's solve for the number of firms here. So notice that I can subtract 50,000 on both sides. And so for determining the number of firms, the marginal cost doesn't matter at all. And so now recall again that the quantity that each firm is going to produce is just going to be given by S over N. Sorry, S over N, that's right. And so now recall that, again, S is 10 million and N is to be determined. So on this side, what I can do is I can rewrite AC as 50,000 plus 10 million all over, apologies about that. So S is equal to 4.05 million, okay? And so, apologies, so I need to change this here. So, so we have the average cost is equal to 50,000 plus 10 million over 4.05 million times N. Okay, and so now, again, I have, just taking this rule down, I should have that 200 over N is equal to 50 million over 4.05 million times N. These millions can cancel out, so that's good. That'll sort of simplify the math a little bit. And so now I just want to multiply by N on both sides, and so I get N squared. And then what I can do is I can just multiply by 4.05 over 10 on both sides. And so what is that going to give me? It's going to give me this. Okay, I can make a little bit of a simplification in just getting rid of this 10 on both sides. And then what I have left over on the left-hand side is 20 times 4.05. And so what's that going to be? That's going to be, give us 81 equal to N squared. If I take the square root of both sides, that just gives me the square root of 81 is equal to N. And so the square root of 81 is just equal to 9. And so therefore the equilibrium quantity, the equilibrium number of firms is going to be 9. Then to figure out the equilibrium price, I just go back to this PP curve and note that it's 50,000 plus 200 over N. And then all I have to do is I just have to plug in for my N star here and notice that that's 200 over 9. So off the top of my head, I don't know how to, I don't know how to divide 9 into 200. So I'm just going to write down that that's, if I've already done the calculation, and that's approximately 22.22. So, so then we can go back to question 3 and plot the equilibrium price and the number of firms on our graph. And so the slides are just saying, hopefully with a little bit better handwriting, the same thing. So question 5 is going to ask, suppose there's a shock and the market size increases from equal to 4.05 million to S equals to 7.2 million. What's going to happen to the PP curve and the CC curve, and the price and number of firms in equilibrium? Well, we can notice that the PP curve is not going to change. And the reason is that the PP curve is equal to C plus N over B. And so the change in S has no effect on the PP curve. The CC curve is going to become flatter because we can recall that the CC curve is just equal to C times N times F over S. And so the CC curve is now going to become flatter. And so the coefficient in front of N now becomes smaller because we've increased S. And so the AC curve is actually going to have a smaller slope. But now, if we just go back and we, again, try to calculate the number of firms, well, again, we're going to have that so if we had the calculation for the number of firms before as given here, well, then all I need to do is I just need to replace this 4.05 with 7.2. And so then I can solve for everything like I did before. So these 50,000s cancel out as before, by subtracting 50,000 on both sides. I'm left with 200 over n equals 10n over 7.2. And then these steps differ. So what I'll do is I'll just get, I'll multiply by 7.2 over 10 on both sides. And then I'll multiply by n on both sides. And so what I'll get is I'll get n squared is equal to 200 times 7.2 over 10. I can cancel out this 10 here. And then 20 times 7.2 is equal to 144. So n squared is equal to 144. Taking the square root of both sides, I get that n squared, that n is equal to, n is just going to be equal to 12, which is the square root of 144. And so now I get the new equilibrium number of firms as being equal to 12. Okay. And then each firm then, if I just plug then back in for the number of firms into the PB curve, or the price that each firm is going to charge, then n now is greater, it's now 12. And so that gives us that the price is going to be lower than what it was before. Recall that the price earlier was equal to 50,022.22, and now it's gone down to 50,000.06. And so the number of firms in equilibrium is increased, and because the number of firms in equilibrium is increased, we now have more competition, and as a result, prices of industrial lasers for consumers have decreased. So we can depict that as follows. The CC curve, it gets flatter because the market size gets bigger. And so as the CC curve gets flatter, we've now pushed out the intersection for the new number of firms, which has gone from 9 to 12, and then the price has gone from down to 50,016 from 50,022. So suppose the sixth question is going to ask us, suppose the government is going to impose a tax on the firm's inputs, laser resistors, which is going to increase its variable costs. So we want to explain intuitively what's going to happen in equilibrium, whether or not there's going to be more or less firms. So intuitively, what we can think is that suppose that we have that here, oops, excuse me, we have P and N, and so again, we're going to have that this is going to be, oops, I need to draw fixed costs. So this is going to be the CC curve, and this is going to be the PP curve. Well, we can note that the PP curve is given by C plus 1 over NB, and the CC curve is just given by the price plus the fixed cost over Q, or equivalently, when we have that all firms are equal, S over N. So the CC curve is going to shift up because we've increased C. And so the CC curve is going to shift up. Oops, excuse me. So this is the new CC curve. And then likewise, the PP curve is also going to shift up. But we can notice that what's going to determine the number of firms is going to be this intersection between the PP and the CC curves. And so I said it quickly, but we can note that if this is this equation, this equating of the PP curve equal to the CC curve gives us the number of firms, then we can note that when we do when we equate the two, we can notice that we can just cancel out these marginal costs, and so the marginal costs never factor into what the equilibrium number of firms is going to be. And so we can note that if this was the number of firms before n star, then the way that that the curves are going to increase is going to be exactly such that that the new number of firms is exactly the same as what they were before, because again, it doesn't matter if we add a tax here on both sides, it's just going to cancel out when we set PP equal to CC. What's going to be different then is going to be that if before these firms charged an equilibrium price of P star, now they charge a new higher price of P prime star. And the reason is because just going back to what the price that each firm is going to charge, well, it's going to be given by this. N star is not going to change, but we do have the C increases, and so the price that each firm charges is going to increase. So just to clear what I've drawn, just to sum up, both curves are going to shift up. The average cost is going to increase as the variable cost increases, which is going to shift the CC curve to the left. And but because of the increase in the marginal cost, the firm has to increase MR, increasing the price and reducing the output, which is also going to shift the PP curve up. The two effects are going to cancel out, and the number of firms isn't going to change. So that's depicted as follows on perhaps what might be a better drawn graph than the way I drew it. So just to wrap up, let's conclude by doing some quick multiple choice questions. There were some comments asking for asking to go over multiple choice questions in sections, so I'm happy to do that. So question 1 is going to ask, if a firm is going to use a production process that yields economies of scale and charges a price equal to blank, then the profit will be blank. So if the firm uses a production process that yields economies of scale, well, we know that, for instance, if a firm charges a price equal to marginal cost, then there's going to be no profits. So price equal to marginal cost is the same as having perfect competition. Perfect competition. And so we know that we can cross out any of these options that ask us about, tell us that when a firm charges a price equal to marginal cost, profits are going to be either maximized, negative, or positive, because here perfect competition tells us that profits are going to be 0. Okay, so I can cross out these. My remaining options are going to be that if a firm charges a price equal to marginal revenue, the profit will either be maximized or will be positive. And so if a firm charges a price equal to its marginal revenue, wait. Sorry. Oh. Okay, so let's conclude just by doing some multiple choice questions. So question 1 is going to be, is going to ask us, if a firm uses a production process that yields economies of scale and it charges a price equal to blank, then the profit will be blank. So we can note a couple things. Recall that if a firm charges a price equal to marginal revenue, if price is equal to marginal revenue, then the profit maximizing rule is for marginal revenue to equal marginal costs. But if price is equal to marginal revenue, then we're back in perfect competition. So if this is true, then we're in perfect competition, where profits are going to be equal to 0. And so anything that says that if a firm charges a price equal to marginal cost, that profits are going to be maximized or profits are going to be positive isn't going to be true. When price equals to marginal revenue, we're in perfect competition, and their profits are going to be 0. And so I don't see anywhere that says profits are going to be 0. So we can cross out these options. Okay, so if a firm charges a price equal to marginal cost, well then suppose that it has some fixed cost, then it could mean that, recall that we had that markups were equal to exactly what price was going to be minus the marginal cost. And so if price is exactly equal to marginal cost, then for instance, if it has some fixed cost, and so its price of producing Q units is going to be given by Q Q times C plus F, then that's going to mean that if they're just charging this marginal cost C for the price, then they'll never be able to charge this fixed cost. And so if a firm is charging a price that's equal to its marginal cost, then that implies that its profits are going to be negative. So the correct answer here is going to be 3, that if it charges a price equal to marginal cost, profit's going to be negative. Moving on to question 2. Question 2 is going to ask, under the model of monopolistic competition, a blank in the number of firms in the industry will cause blank to blank. Okay, so let's, I think the easiest way sometimes is just to think about each of these in turn. So let's think about the statement that number 1 is telling us. So under the model of monopolistic competition, an increase in the number of firms in the industry will cause average price to decrease. So let's just look at the PP curve and ask whether or not that's true. Well, the PP curve tells us that the price is equal to the marginal cost plus N over B. And so if we increase the number of firms, then that will cause the average price PP to go down. And so 1 seems right. Then question 2 is saying an increase in the number of firms in the industry will cause markups to decrease. So recall that markup is just given by P minus C, which again here is given by 1 over NB. So again, if N increases, then P minus C, this is going to be markup, which is, I'm just going to find as mu. So I'm going to call this markup. That increases, so I agree with 2 as well. Formulation 3 tells us that the average cost is going to decrease as the number of firms in the industry is going to increase. So just recalling the CC curve, well, the CC curve is going to tell us that the average cost, or the CC curve, so I call it CC or AC, is going to be given by the marginal cost times or plus N over F over S. And so as N increases, notice that the average cost is going to increase. And so this statement cannot be true. Therefore, the correct answer, because I've already said 1 and 2, must be number 4, that A and B are correct. So I know Dennis has been including animal videos at the sort of middle of his sections, but I wanted to show him up a little bit and sort of include my actual animal in my videos. So this is Atticus. Hello. Hello. He's my little rat. And he's such a very nice guy. He's... ah! Hello. This is my other little rat buddy. He's hanging out in a pasta box right now. His name is Mr. Tibbs. He's very silly. Oh, hello. Hello. Anyway, I hope you enjoyed seeing my two rats. They certainly, as you can tell, like to escape, and so a little bit hard to show off on camera. But anyway, I've enjoyed having rats as pets during COVID, and anyway, I hope this was a little bit of fun just to throw at the end. And I'll see everyone again in 2 weeks. So thanks so much.